Hello everyone, this is Yuvram and welcome to my tutorial about series of tutorials about how to use ROS, how to get started with ROS. So if you are in the field of robotics, or if you are a hobbyist or a professional or a student who is looking to know or do cool stuffs in robotics or artificial intelligence or say machine learning and all those tricky areas, he would have very well came across the name robotic operating system, or shortly called as ROS. So what is it first of all, and what's it what makes it so unique, uh, and what makes it the buzzword around this field of robotics. So that's why I started to make this tutorial on how to use ROS and what are the cool stuffs in ROS, and let's and had a plan or have a plan of making some cool stuffs, making some projects with ROS. So eventually we are going to build a robot, AGV, AUV kind of robots, autonomous robots using ROS and their core features. So let's start with our introduction to ROS. So what is it? So ROS, as I said, it is robotic operating system. So if you go to their website ros.org, you will came across this nice paragraph where they will explain what ROS is. So according to them, ROS is a flexible framework for writing robot softwares. So what is a robot software? Firstly, so the thing which runs on your microcontroller or a mini PC or your laptop or your server, which is controlling your robot, the end effector, the thing which does stuffs for you. So the software which runs on your robot's motherboard or the main processing environment is the robotic software, and ROS makes it easier to your software write your software. So that's what that statement means. So ROS is a framework, flexible framework, which is used to write robotic software and making the process much easier. So ROS is a collection of tools. So it has a lot of tools which we are going to see in the next few slides. A lot of tools, a lot of libraries, which makes it ideal for using it in creating robotic software. So next, we'll go to the next slide and see what's that. So who built it? So is a ROS thing. It's so easy and it's so spread across. But who actually built it? So the answer here is there's no a person or a company or enterprise behind this software. It's just enthusiasts around this world, and people who are frustrated about writing their software again and again and again without any advantage of reusing their codes, or without a common approach to a common problem. So these guys write ROS in piece by piece. So they just contributed to this open source project. So mainly there are in their website they just gave a few list about a few laboratories who who just helped them, who just gave their codes to the ROS so that they could make a better uh, common way of reusing their codes. So for example, if you just say you know a person who knows how to how to address a robot problem, maybe a vision problem. Say for example, this guy, your friend is very good at writing computer vision program. He could find different kind of stuff. He could pick a color, pick the depth, etc. And but he is not well versed in how to localize or how to control your robot. Let's just say he doesn't know how to use PID controllers, and there's another guy who knows how to use PID controllers but not the vision one. But there's a need for a common way to share their codes, share their works, share their knowledge. So that's what ROS is all about. So all these laboratories out there in this world, they just contributed their specific talents in form of codes. So what ROS did is they just took all those things, they just built it into a common platform, and they just gave it to the world. Like, go ahead, take all those things. This is all you were going to need up till now. So that's it. Go ahead and work with it. So that's what ROS is about. So, and is ROS free? I mean, come on, it has a lot of features, but is it free? Because I'm a student. I'm not going to pay much. I don't be affording much for a piece of software, right? But you're lucky. ROS is free. Yeah, and it has a lot of permissions. It is granting full permission for commercializing your program which uses ROS. So if you just create a fascinating robot and just want to sell it, you can very well go ahead and sell it without going into any legal problems. But do contribute to ROS societies. But I mean, they do contribute to ROS societies. How powerful is ROS? This is a bit of an odd question right now because we just have started this tutorial. We don't know how to use ROS. So let me just give you a scenario. You just built your robot and it works fine. Suddenly one day you just broke some of your sensors and you just want to swap it with a new sensor, which your code is, your robotic software is not supporting. So what you got to do is you just have to rewrite the software entirely, or a big part of your program to adapt to this new sensors. But if you use ROS, just imagine a method to swap just the bit of the sensor program with a new sensor program without touching anything related to other components. Say for example, you just have two wheels. You don't have to care about localization, you don't have to care about mapping, you don't have to care about say for example, obstacle avoiding, I mean other features, PID controllers. You don't have to care about all those things, just have to change this sensor program, so it will be easy, right? So that is the powerful thing of ROS. Structure of ROS. So this is how your ROS is going to look like. So I mean, not like this, but ROS has mainly two things: a core ROS core, and it is connected to a lot of nodes. I mean, you can have n number of nodes, and these nodes can be on different systems. So just have your main computational program running in your server or your laptop or a computer, and a small program which is going to control your wheel movement or sensor alignment or something, servo control, pick and place control on your onboard robots computer, robot system. Say for example, Raspberry Pi, BeagleBone Black. So these small bit of program, which I mean, those small programs are called as nodes, and the main thing which is controlling all those nodes is called as ROS core. So they what had happened is these nodes talk with the core via messages. They will just send their message to this core, and basically the core is not going to do any kind of computational stuff, and he's just going to sit there ideally collecting all those messages and passing those messages to the next node or the node which needs it. So that is what this structure is explaining. So there are a lot of nodes, they are connected to each other through a message topic. So the process of giving the message is called as publication, and the process of seeing those messages and acting to it is called a subscription. So this is all of it. That's it. This is ROS. So that's it. This is ROS. Basic features of ROS. So these are the basic features which you can find it in your ROS website. So communication interface, so the way the thing which I just say, messaging, so publishing and subscription, this is called as communication interface. The main thing is it provides a way to communicate between multiple computers. I mean, across LAN, across WAN, you can just communicate with all other systems in your network, in your wireless, in your local area network or a wide area network. If you have ROS and the needed subscription and the publishing methods, so you can just communicate with all those things without you don't have to care about, or you don't have to work on the communication part of it. Say for example, you just don't have to care about the socket programs or TCP/IP. ROS just takes care of all those things. Code reusability, as I just said, you can just swap those codes. If you like your sensor code, you can copy it and use it to another project. You don't have to recreate it. So that's a use. And robot, this is the main thing, robot geometry library. So not everybody is good with Max, right? No, not every person is good with Max. But if you take a robot, a simple robot, you don't look for aesthetic values, you don't look for their geometrical property. But if you go beyond your level, and if you're you're building a thing which relies a lot on stabilization, a lot on distance covering. Say for example, a AGV which should have a turning radius of say 2 meters, not beyond that, or not short of it. So all those things you have to be good with Max, and especially with geometry. So what ROS does, it just gives a bunch of libraries and a easy method using which you can learn how to use geometry in your project. So it just makes the deal very easy. So it just does all the mathematical calculation for you and makes your life easy. Robot description language, this is something like AutoCAD. Just use this programming language to draw your robot, not not prettier, but just main features. And this is what we will be using in ROS. I will tell you, then in Gazebo, a simulation software and all those things, we are going to use this. ROS is nothing but a tool, a C++ tool, which is used to visualize your sensors value. You just want to see your sensors value, you can use ROS. And RQT is graphical user interface buildings package. So Qt creator, if you are around C++ for long years, you would have known Qt creator. It's a way of building GUI interfaces. So RQT is specifically for ROS and much more. You will learn all those things. So topics to cover, that's it. This is what I have planned right now. I have planned to cover in my tutorials: installation of ROS, workspace creation and basic tools, message sending and receiving, how to use ROS specifically in image processing, video sending. What ROS brings to the table on the field of image processing, on the field of machine learning. I'm good with machine learning, so I'm going to throw that at you. Machine learning, artificial intelligence, and we will build some robots with this. And basic tools like ROS, RQT, Gazebo, and ROS. We are studying ROS, how to build a robot. So we are going to build a robot. So that's it, guys. I will see you in my next video. Take care. Bye.